Good morning everybody and welcome to EQUA webinar, and today's topic is the glazing, and this time this webinar is given from Finland, and my name is Mika Vuole. I'm CEO of EQUA Simulation Finland, and I have worked with the eighties since 1995, and I'm part of the development team as well. And here I have Erkki Karjalan with me, and he is acting like a co-pilot here. He will help me all the practicalities. So during this presentation, you can raise your hand and make questions, or you can write your questions or comment on the chat mode, and Erkki will handle them and answer them. And of course, inform me that if you have some questions that has common interest. And we will recording this session as well, and within a couple of days you will get the email and links to the recording, so you can look this one afterward. Okay, welcome everybody. So I have used lots of the phrase that the window is one of the most important components in the building. It has major influence on lots of things. For example, it has thermal conduct, U value is rather high, so it has high losses and a big impact of heat thermal losses of the envelope. Daylight, cooling load, visual comfort, and etc. and etc. And window itself is quite complex. There's lots of thermal phenomena going on in the window glazing. On the left hand side there is a sun, and you can see the red arrow, which is the solar radiation, and part of the radiation is reflected from each pane, and part of that radiation is absorbed into the panes. And of course the pane can be the shading layer or slats, for example. And once they are heated, then they will get the board convection between the panes and the cavities, and also thermal radiation between the panes. So taking that all account, this is a rather complex model. Typically, these in eighties we have two different window component model. The first one is the standard one, which deals the whole glazing package as a single unit. So in this picture you can see the right hand side arrows, which is this is G value. So it's a total heat transfer into the zone as a convection and thermal radiation from the heated pane. That's the arrow in the bottom of the picture to the right hand side, and part of that is the solar ray transmittance, which is this arrow here, and that's the part of the load that you can actually see. And once this is radiation, it will heat up the constructions instead of air. So from here you can see quite easily that you have single equation and you have two unknowns, and this is the reflectance back to outside, and also the absorbent, part of the absorbent which is going outside as a convection and thermal radiation. So this kind of standard window model you shouldn't use once you have, for example, double sheet facade here, and then because this information is not know how the deviation between the reflectance and absorbance back to outside could be handled. And the same thing with the radiation from the inside. So with the standard window model we do our best approach that we can handle that one as well. but it's window itself, it quite commonly it's not symmetrical, so we don't have that information what are the G value and solar transmittance from the inside to outside. Okay, let's go then to the eye-to-eyes application. So here you can see the standard eye-to-eyes window model, and the part that we are dealing right now in this webinar is the window glazing. So the glazing are defined with these four key parameters. That's the G value, which is the total heat gain into the zone, and then T, which is the solar transmittance. That's a solar direct radiation which is coming through the whole glazing package. And then the part of the solar radiation is in the wavelength of the visible transmittance, so it's treated separately. And here you can see the glazing U value. It's quite commonly used as a constant over the year. And end of this presentation, I will show that it's not the case. And actually, this U value is not used in the standard glazing either, because the surface resistances are neglected, and the surface resistances between the surfaces are kept constant. And surface resistances, the convection and long wave part are treated separately, and they are calculated in every time step as a function of in outside as a function of air speed and in wind direction, and inside we will calculate that maximum from the natural convection or forced convection. And the integrated shading devices are given as multipliers with, to these four key parameters, and they are described here. Multiplier for G value, T value, U value, and also the diffusion factor. So it means that a direct radiation after the shading layer can be transferred from the direct radiation to diffuse one, and then it's treated as diffuse after this layer. And of course, you describe here the glazing properties as G value and T value. The angle dependencies is taken account, of course. But once you have a case that you have lots of glazing, lots of radiation from inside, and double sheet facade, for example, then you should use the more advanced window model. We call it detailed window model, and I will add it here, so its icon looks a little bit different, and I add it here. So now we can see that this looks a little bit different, and here you can describe the ventilator's construction and make double sheet shade, but it's not today's topic, so I will concentrate on these glazing properties. So instead of one set of parameters, the whole glazing package, we describe here all the layers from outside to the inside and describe them pane by pane. So here I have two pane window, and from here you can see the actual properties of the glass pane. So transmittance is described to the short wave one, total short wave, and reflectance to outside and inside surfaces. And please note that these these can be different ones. As you can see here, there's small differences, but it could be much higher, bigger one as well. And also the visible factors and the diffusion factor, that it could be transfer direct radiation to the diffuse one. And then as we have long wave radiation, thermal radiation is treated separately, you can describe the emissivities as well. And also the glass pane thickness and the lambda value, which is actual key K here, because it's on those standards it's has such a symbol. And then the pane, the caps are defined as a material as well. And here you can see that the thermal conductivity, viscosity, and specific heat value are treated as a function of the temperature, and the actual equation you can see here. So these are the factors A and B described here, and here's actual values of lambda, for example, at the temperature 0 Celsius degree and 10 Celsius degree. Just an input echo that you will know that you have done the right job. Okay, and then I add here a shading layer, a Venetian blind layer, and I can select from the database, I can select one from this one. For example, I will pick that. And for shaded layer, oh sorry, this is the Venetian blind. It doesn't matter, let's go with that one. For shaded layer and the slat material are described similar way as the pane. So all these parameters should be defined, but the shading material, it has some openness factor as well in this one, how much there's air gaps between the on that shading layer. Okay, that's the material properties that are given. And also you can, in this case of the slat Venetian blinds, you can describe the slat spacing, slat width, and also the slat angle. And this can be negative as well, so they can be inside, could be transferred to the outside. And this slat angle could be controlled in the advanced control feature of the solar shading. Okay, and once you have described the detailed window model in details, then we have this glazing properties after reference conditions, and now it will give you as a feedback what kind of glazing package you have made. There is G value, T value, TVs, and the glazing U value. And please note that, for example, this U value is given in the reference conditions, so it means that there is a plus 20 degrees inside and 0 degree Celsius degree outside. So this U value is calculated with those temperatures. And once we are, for example, in Finland, we have design conditions minus 26. So this U value varies a lot due to internal convection in the cavity. And I will show that later. So these values are not used during the simulation. This is just the checking that you have done the right job. Okay, and once you have done this one, and then there's an option to close to this slot, the reference that it will calculate the actual values, GT, visible transmittance, U value, and diffuse factor without and with shading. And you can save these class constructions as a database object and use that in the standard window model. And also the same thing with the integrated shading. So if you don't have information to the standard window model, what are the actual factors of integrated shading, so you can calculate them with this feature if you have that information. Okay, so these are the features that I wanted to show, and I had here an example that I prepared beforehand. So I have single zone here, and the location is in Finland, in Helsinki, and it has normal reference year. And the window shading, glazing is described in that way that there's a 3 pane, and the second cavity is an argon. And here you can see that this red arrow here, it means that if I open the pane here, it means that it has low emissivity outside. So it will help us to get a better U value, and this U value is 0.9. So I have built a model beforehand, and from the zone, here's the detailed window model, and I have made a full year simulation, and I have logged a couple of those U values. Here's the U value without surface resistances, so you can see how much it varies the actual glazing package resistance. So the surface resistance is not included in this number, but you can see that it varies around between 1.04 and 1.26, so quite a big variation. And this is just an interesting result. So actually during the simulation there is a heat balance to each pane and each cavities. So this is just a result. This is not part of the simulation. This is for visualization. And you remember that the U value was 0.99. So here is that U value with the fixed surface resistances. So you can say the variation of the U value from air to air, that kind of thing. Okay, those are our glazing models, and introduced by same detail. And I recommended that you are using this detailed window model when there's a solar radiation from inside to outside as well. For example, corner room with a lot of glazed surfaces. And we have to remember that even if there's a single window in the zone, there's always some reflection which is coming back from the zone after 1 or 2 reflections. Actually, we are using the zone model, we are using ray tracing method to calculate that. And double sheet facade is the case, and actually we don't allow to use standard window model with the double sheet facade model. And if you have some slat angle control, if you have more detailed daylight calculation, and the this detailed window model, it has also better accuracy to angle-dependent T and G value. And the main advance is that you can add any sunshade into the model and get angle-dependent calculation with the Venetian blinds. The main drawback is, of course, that it needs quite a amount more data, and you have to adjust pane data until you will get the given U values of the product. And this will be much improved once we will get spectral calculation and spectral data from the glass suppliers. And this is something that we have already shown as an early beta in our Power User Day. And it will be published, I guess, in 4.8. That's at least right now. It's in our list. Okay, thank you very much. And now it's time for questions if you have, and a little bit discussions as well. Erkki, do we have any questions there? No raising hands. Okay. Thank you very much, all of you, and I will close this session now because there is no raised hands and no questions.
Saatko sen attendance-listan näkyviin?
Joo, mulla on se näkyvissä.
Soittaa sen on rest handin mukaan.
Mitä mä pystyn tekemään?
Sitten vaan toi. Rest handin mukaan ja...
Okay, Manuel, now you can make a questions, I guess. I have unmuted you.
Hello? Hola?
Yes?
Yes, I have a question.
Yeah?
You hear? Oh, yeah. Is it possible to give a value to the linear bridge between the glass and the frame?
No, not right now. It's the thermal bridges are defined right now only with the here as surrounding perimeter of the window. Yeah.
So we have to integrate it in it.
Yes, that's right.
Okay. Yeah. Yeah, that was it. Thanks.
Okay, thank you. And
Jos kysy myös tuonne questions-osastoon.
mitä hän kysyy?
How would you model a facade with different layers, closed and opened? Sama nimessä kysymys.
Florian, I don't. Florian, can you repeat your questions? That what was your question? No sounds from Florian.
Nyt sä näet sen kysymyksen siellä questions-listalla. Ei se uskalla puhua.
Enpä näe sitä.
On pohjimmaisena.
Okay, I can't see your question here, Florian, so let's come back to that via email. Manuel, you have raised your hand, so what is your question? nothing from the manual. So, and unfortunately, I have some technical problems here. I can't see your question in my panel at all. It's disappeared something.
That's a chat.
Ei ole chatissa mitään.
Ei, mutta sä näet sen.
Näin. Please wait a while. Eric is trying to sort out this technical problem and hand out questions to me. So let's wait for a while.
Sä näet siitä.
G-value and differences between G-value and CH gain. Okay, let's go back to the simple one window model. If I click it open, here at the glazing, the G-value and CHCC is the same one. And here is this is shading coefficient as single one, absolute value. So the reference is the whole without any pane, any window. And if you are working in the US market, then you have to describe that as a reference to single pane window. And traditionally in Sweden, the double pane reference, double pane window has been the reference, and then every window is described as a factor F and F2 as a ration of the behavior double pane window. The next question is from Florian. How do you model the facade with the different layer box type window? Okay, then we have to introduce the detailed window model to the reasons that I tried to explain. So once I have this internal window here, so I can select the ventilated construction on the whole wall, all on top of the window like this. And then once I have selected this one, then this link is available, and I can describe what is the so-called front panel in this windows here, and this is glazed panel. And then you can describe the cavity distances, opening areas, possible return airflow from the ventilation, and also the leakage between this cavity and the room. Okay. Can you scroll that, Erkki, if there's more questions? No, nothing. I guess that we are now handled them all. Okay, so thank you very much, and you will be informed once this recording is published, and we will do a little bit production that we will cut out the pauses and stuff like that. Thank you very much. Have a nice day.